Antarctica, the coldest, driest, and most remote continent on Earth, is undergoing a quiet infrastructure revolution. In 2025, nations from around the globe are investing in science, logistics, and sustainability to expand their presence on the ice. These projects aren't just about buildings, they are high-tech lifelines supporting cutting-edge research, climate monitoring, and international collaboration in some of the most hostile conditions on the planet. Here are the top 10 infrastructure developments transforming Antarctica in 2025. 1. Antarctic Infrastructure Modernization Program, AIMP, McMurdo Station, USA. The U.S. Antarctic program's $355 million modernization of McMurdo Station is the largest infrastructure overhaul on the continent in decades. Scheduled for completion by 2026, the project includes new interconnected buildings, a centralized operations facility, a cutting-edge information technology center, and modern lodging capable of supporting scientists and logistics personnel year-round. Designed with modular, energy-efficient construction, AIMP ensures the station remains operational for the next 50-plus years of polar research. 2. Discovery Building, Rothera Station, UK/BAST. The British Antarctic Survey's new 4,500 square metre Discovery Building at Rothera Station marks a leap forward in polar architecture. Set to open in 2025, it consolidates laboratories, operations, spaces, offices, medical facilities, and recreation under one ultra-insulated, solar-assisted roof. This structure replaces decades-old facilities with a focus on smart systems, lower carbon footprints, and resilience to polar storms. Engineered to withstand winds over 100 km per hour, it includes integrated solar arrays and passive design elements that reduce heating demands, making it a flagship in sustainable Antarctic construction. 3. Rothera Wharf and Runway upgrades, UK. To accommodate the UK's state-of-the-art research vessel, the RRS Sir David Attenborough, the Rothera Research Station completed a major wharf rebuild in 2024, alongside substantial runway enhancements. These upgrades allow for safer, more efficient delivery of supplies, fuel, and personnel during the brief summer window. The runway now features new lighting, drainage systems, and better access points for all-weather aircraft, ensuring that scientific missions are no longer weather-dependent. 4. Scott Base Redevelopment, New Zealand. New Zealand is undertaking an ambitious $344 million New Zealand dollars rebuild of its iconic Scott Base, replacing outdated 1970s-era structures with sleek, prefabricated modules designed to thrive in Antarctic extremes. Though fully completed by 2028 to 2029, the project has gained momentum after rebooting in 2024 following cost reassessments. The new base will include living quarters, labs, engineering hubs, and energy-efficient systems that reduce fossil fuel dependence. Its modular design, constructed in New Zealand and shipped south, limits on-site building time and minimizes environmental impact. 5. Macquarie Wharf 6 upgrade, Australia. Though not on the Antarctic continent, Hobart's Macquarie Wharf 6 is a vital southern gateway to the ice. The $188 million Australian dollars upgrade, scheduled for completion in 2025, prepares the port for increased polar traffic, especially the Australian icebreaker RSV Neumayer. The new wharf includes reinforced docking capacity, enhanced fuel loading systems, and faster cargo handling to reduce turnaround times. This infrastructure enables Australia's Antarctic division to expand the volume and frequency of supply missions to its stations. As a result, Macquarie Wharf 6 becomes a critical logistics lifeline to East Antarctica, enhancing the resilience and scientific capacity of Australia's polar operations. 6. Zhongshan and Qinling stations, China. China is rapidly expanding its Antarctic footprint. Zhongshan Station now features a satellite ground facility enhancing real-time communication with remote instruments and orbiting satellites. Meanwhile, the recently opened Qinling station, a 5,244 square meter base operational since 2024, serves as a new logistics and science center in the Lasaman Hills. Plans are also underway for a seasonal station in Marie Byrd Land, signaling China's westward expansion across the continent. These bases are designed for multidisciplinary research, glaciology, marine biology, meteorology, and even space weather monitoring. 7. Taishan Station, China operational since 2014. Taishan Station is China's seasonal base located at 2,621 m above sea level on the inland plateau between Zhongshan and Qinling stations. Though compact, it plays a crucial logistics and refueling role for long-range traverses into the interior. Built in just over a year using prefabricated methods, it remains a model of rapid Antarctic deployment. The base supports up to 20 researchers during the austral summer and includes basic living quarters, power systems, and scientific workstations. Its strategic position makes it a relay hub for China's broader inland scientific objectives, including deep ice core drilling and astronomical observations near the South Pole. 8. Neumayer Station 3, Germany. Germany's Neumayer Station 3 is a marvel of engineering located on the extreme ice shelf. Though completed in 2009, it remains one of Antarctica's most advanced research platforms, built to withstand snow accumulation and shelf movement. Mounted on hydraulic supports that can be raised to prevent burial by drifting snow, it continues to support meteorology, geophysics, atmospheric chemistry, and seismic monitoring. With renewable energy support systems and a full suite of satellite communications, Neumayer 3 serves as Germany's year-round outpost and a collaborative science node for European researchers. 9. Vostok Wintering Complex, Russia. Russia is in the final stages of constructing a modern wintering complex at its iconic Vostok Station, the coldest permanently inhabited place on Earth. Slated for full operation by late 2025, the new complex replaces aging Soviet-era facilities with improved labs, power units, medical wards, and insulated living spaces. Operating at a location where temperatures dip below -89 degrees Celsius, the station requires specialized engineering, such as vacuum-insulated walls and low-maintenance diesel-electric generators. 10. Cryoscope Telescope Project, Dome C, International. A collaborative international project, the Cryoscope Telescope is an upcoming 1.2-meter cryogenic infrared observatory set for prototype launch in 2025 at Dome C, one of the most stable atmospheric locations on Earth. At 3,200 m elevation, far from urban light or moisture, Dome C offers unparalleled viewing conditions for deep space observation. The telescope is designed to operate at extremely low temperatures, reducing thermal noise and enabling detection of faint cosmic signals in the infrared spectrum.